Okay, my friends, it's Roger once again, and again, we're going to do nuclear physics today, and within the next 10, I don't think it's going to take more than 15 minutes, you will be smarter than any nuclear physicist breathing oxygen at this moment, except me. Now, this is electron flood theory. The core of every atom consists only of electrons. Now, if you've been following me, you know this quite well. These are the electrons. This is a helium atom. It has enough electrons in the core to be equivalent to 2 protons, 2 neutrons, which is, it ends up being 7,350 electrons in here. Now, the positive ones huddle in the center, the negative ones surround them, crushing them in, and then these negatives try to come in, but these negatives keep them away. It's called the strong force and the weak force. Photons are made of a box of electrons, just like this, and I will show you that uno momento. And when they are at rest and everybody is at the same temperature, they sit just like this. And when they are being forced against other electrons, that is called heat, they concuss and glow, and depending upon how much interaction, how much glow. Now, this is light. This is a red pulse laser, and it is just coming through the air, not concussing too much. And then Rod Warren designed a Venturi that is here that accelerates the light particle, and it pulls it out of the way of its concussive magnetic region, because it's in here. But as it goes, everybody out here has to get out of the way because it's like a ball of magnetism. Now, he's accelerated it, so it pulled it right out of the ball. And it's being sucked right out of there. And as it does, as I said, when they concuss, they glow. I can't explain that, but they glow. And only the red ones glow. Only the white particle part glows. And then it just becomes concussive and glows all over the place. I go through this in extreme details, and I'm sure too much for most people. Now, as I told you before, they create a box of electrons. That's what I consider to be the photon. And this is, as they slow down, we can see them. And when I say slow down, yes, light can accelerate, and light can slow down, and light spins, and light actually can create this kind of an effect, which this is the only one I've ever seen of this. And I think that's an antiparticle creating a whatever it is. Now, this is, I have no clue. This is the accelerated light spinning to the right, which is the right-hand rule, and it's drifting to the left, which is what we see. And this is concussing, it's getting tighter and tighter, so it's slowing down. Now, as I told you before, these particles, there's a strong and a weak force. And the black part can walk right away from the powerful part. The black ones will actually touch each other and not, like, they'll be huddled up in the center. That's okay, they don't mind that. The red ones, which in the case of normally they're going to be white, they won't touch each other. They want to push away. They concuss. You try to push one against the other, they'll go just so close, and everything's okay. Yeah, you can stay there, no problem. You get a little tighter, they start to glow. You push tight, they glow more, they glow more, they glow more. And then all of a sudden they ignite. I mean, literally. All right, now let's look a little deeper. All right, I know I've shown this a bazillion times, so don't yell if you've seen it, because some people haven't. All right, now, this comes through here, as I told you, these are a box of electrons, and they're positive, negative, all the way around, touching each other in this manner so that there is no problem. Every plus has a minus and every minus has a plus. But when it comes through the air, because they are polar and the particles in the air are also polar, they start to bang and turn into this right-hand spin. There's the black dots. There's the black dots. You see them? See them over here? You see them? Now those black dots are willing to go right up against each other. You see, there's two of them right on top of each other. They're right on top of each other. They don't care. They don't care. You see any white, the white is just exploding like a bomb. It's trying to push everybody out of the way and creating this enormous energy field, which is the strong force. The weak force just rolls away. It comes back in over here. We could see them reincorporating into the white. But in the interim, they just get out of the way. Now, I don't know whether they're sitting around in the air. They can't be. They have to be attached to the white particles. So they're laying out there in the air in the electron configuration, because we know there's static everywhere. You walk through the air, you collect static when it's a dry day. It's all over the place. So there's free electrons all the time in the air. It's actually called ether. And there's free electrons even in rocks and everything else. If you forced enough electricity in there, those electrons would flow through there. And every time it warms up, there's extra electrons in there. That's all it is. There's always extra electrons in everything. So they've missed a lot of the basics and always assumed these things based on Einstein and all of these other guys. I'm sorry, every single one of them was wrong. Not a single one of them was right. Just a fact. Now, I'm not saying that they didn't observe things and they weren't making extremely intelligent, understandings of what they were seeing. But they were basing it on a false premise of these big positive core and a negative floating around the outside. This is impossible. It was never possible. I knew it was never possible. I just never could prove it until now. And now it is absolutely proven. No question whatsoever in my mind. If anybody from the physics community would engage, they're going to see. This is, show me I'm wrong. That's what I want to see. Show me I'm wrong. Show me where any of these other theories can hold water against this. Somebody. That's what I want to see. And nobody can, and the refusal to engage is status quo in academia. And that's why nothing ever gets done. It's just they just continue to try to walk around in circles pretending that everything's fine. They're whistling in the woods. Okay, now, don't forget, Rod and I have been showing that the boson can separate from the fermion for years. And finally, I've been just really being very kind of aggressive about it. So I believe that's the only reason they're standing up and admitting to it. So this goes back 6 months ago. New boson appears in nuclear decay, breaks standard model. Now, there's somebody in there is taking credit for it. But they say that it goes back years that they understood this. Now, here's another one. Okay, as you know, this is my interpretation of the nuclear core, and if you broke that into little pieces, you might get a chunk of here, a chunk there, big chunks, little chunks, but the basic components are these single electrons. Now, they are finding these particles, and they're saying, oh, this one has a plus, this has a minus, this one has no charge. Well, they're the same particles, they're just interacting in different manners. But they have found now particles they can't figure out, because they might be like a chunk like this. It's not one single one. They want to get down to the single ones. Well, Rod and I are at the single level to begin with. They are digging through debris. That's the problem. All right, here she's going to explain that lepton universality has been obviously not correct, and they have to change. Now, however, they've already made the assumption there's just some other particles that they didn't realize, that they're all right, everything's right, except there must be some other particle that they just never saw before, which is 100% wrong. The correct interpretation of what happened is that they never saw like a chunk like this before, and this is so stable that they can't account for it. All right, and this is because anything can be made of anything because they're all being made of the same particles. Well, listen to what she has to say. And here's the problem with physics and every science. They rely on the old thinking and they never go back to the basics.
On universality seems to be violated. Well, what that means is that there's something wrong with the standard model. We found the crack, finally, in our understanding of particle physics. There's absolutely no way that we can explain this observation with our current understanding. In fact, the only way we think we can explain what's going on is if there are new particles in the universe associated with new physics processes beyond those that we understand, and that these new particles are interfering with the B mesons as they decay and suppressing the decay to muons compared to electrons. Now, if that turns out to be the case, that will truly be momentous. Forget the Higgs. This will be the first sign of physics beyond the standard model.
It's obvious. Anyway, let me show you what she's talking about when she talks about the Higgs, because that was the big deal not long ago, but it pales in comparison to charge separation. Okay, this is the results Rod and I got using a very inexpensive pulse red laser through a Venturi slit, which means that everything is restricted through a curved spaces, and we use 2 round cylinders, and it forces the light to crash into itself. So we didn't use any other special devices. I don't know what they used, but I do know that we had spectacular results using only light. So the particles we're seeing are Higgs fields from light particles, not from big chunks of protons and neutrons which don't exist, because as I showed, everything is electrons. Now, if we can separate the charge carrier from the charge, which we did, that is spectacular. Now don't forget, not only can we see the strong and the weak force, and we have seen them in their box configuration, we can also see them actually charge separating, the black spots separating from the white, and the white becoming extremely concussive and radiating backwards as well as forwards. Not only that, when we see, this is a single slit, so these are interference patterns due to the spinning nature and the pushing away of the white particles from each other, creating like pathways to try to keep away from each other. The black ones just roll back in. Totally different, and they say there's a boson and there's a fermions. These are fermions that explode, and the bosons are the charged particle carriers. They just hang around with the white ones until the white ones have a job to do and explode. Basically, that's as simple as it gets. Okay, my friends, this is bizarre. This just came out today. My friend Pedro, who was with NASA and the European Space Agency and all this stuff, he's really into all this research, sends me a ton of stuff. Well, discovery unlocks hot electrons for more efficient energy use. Well, they're putting it through a Venturi, it looks like to me, and they do talk about how they're energizing the light. Let me find a place down here, measuring energy distribution. All right, here it is. I highlighted it. While hot electrons can have temperatures as high as 2,000 degrees. Remember I showed you that really bright white spot there? That's going to have a high temperature as well, but it's a very confined area, so it's not a big deal. It's their high energy, though. The electron energy is actually separated, it's so high. Rather than the material temperature, it makes them useful for energy technologies. In solar panels, energies from hot electrons, which are the ones I just showed you, could be more efficiently converted to electrical energy compared to conventional approaches. They can break through the PN junction, the positive-negative junction. In transistors and so, it's called a PN junction. Now, Hot electrons also could improve the efficiency in energy technology such as hydrogen-based fuel cells in cars by speeding up chemical reactions. We can see they're breaking the particles apart and they have to come back together instantaneously. So when they do, we maybe can break them apart and let them come back together with what we want them to come back together rather than what they were originally attached to. Okay, my friends, I guess that's about it. I'm going to disengage for the moment, but if someone would like to talk about this on a level that they are, you know, in the expert realm, I certainly would like to do that. Now, as you can see, this is that pulse red laser, and these are Higgs fields just slaughtered everywhere. However, this one here is being pinched on both sides and is forcing it to elongate and turn blue, which is a higher frequency, and then it drops back down. This is all extremely new, extremely interesting, and I think I'm starting to understand it extremely well. So it's time to change the atomic model, as the Royal Institute says, and as all the top physicists are saying now. So if you want to hang in to the old style and just keep spouting out the words that were read to you, that would be the norm as far as I can determine. But it's time to stop that stuff. It's time to engage. Now, if I'm wrong, and you can show I'm wrong, I'm all for that. But if I'm right, and you just turn your eyes and say, no, you're wrong because Einstein said something a long time ago that is obviously wrong, but it doesn't matter anymore what's right or wrong, it doesn't seem. It's because you will be attacked if you go against the mainstream of your colleagues. They call it peer review. It's peer destruction, really, is what it is. You cannot present anything that either makes them look like they're silly, which it does, or diminishes their status, or puts you outside of your circle of friends. That's the problem. And I went back to all my old work, and it's hilarious because I confronted my professor about this 50 years ago. I said, there's no question whatsoever these are dipoles in the nucleus. And he wanted to hurt me for that. But I ended up forcing him to take a test against me about just the general nature of what they say. And he failed. And he ended up giving me the A. You know, I fought this stuff for years. And I'm fighting in every other realm right now. Because I'm telling you right now, the things that they read to you were read to them. And then was read to the person before them. And the ones that made up all these little tricky little, you know, constants and principles and, you know, things that aren't, they were based on their ideas, not based on the actual trueness of the facts. And once they're accepted, then it becomes literally almost impossible to change it. So if you showed this to your professor, I want to know what was their reaction. What did they say? They say, oh, well, forget about it, this guy's crazy? Or did they say, well, you know, there might be something to this, doesn't matter because I'm going to teach you what I'm going to teach you. I very, very seriously doubt whether they're going to incorporate this into any form of truth. And I got a feeling they're going to belittle you and demean you. That's what everybody's been telling me. Everybody's getting the same stuff because I do the mud fossils too. And that's the same thing there. They show the evidence. They show the DNA reports. They show the specimens. They show the anatomists. They show the chemistry. And they laugh at them and then turn around and walk away and have zero to be able to override these obvious evidence in all of these realms. So that's what we're up against. Now, that's what I mean. I hate to keep going down this pathway, and I end up sounding very frustrated because I am very frustrated. when the people that are in charge of the academics are in charge of education, telling you what's right and wrong, and refuse to engage with evidence that absolutely destroys the things that they are telling you to believe, then I find it very, very difficult to be silent. And I think that's the only reason we're starting to see things start to loosen up a little bit. And they are starting to loosen up a little bit. And I have to understand, I understand that it's very difficult to stand up. Trust me, I fully understand that, because I've lost everything that I had as far as people in my life. 100%. You know, in my family and everything. You know, I mean, I get along. We still bump shoulders here and there, but you know, it's just about it. Once you go away from everybody else's thinking, you're on your own. So I'm hoping that I'll have a few more people coming my way. It's lonely out here, man. All right, I love y'all.